RS-25 engines lit. 4, 3, 2, 1. Booster ignition. And liftoff. The crew of Artemis II now bound for the moon. Humanity's next great voyage begins.
Space presenter Dallas Campbell was one of millions following the recent Artemis II mission, a mammoth 685,000-mile journey around the moon. 4 astronauts blasted into space on a 322-foot rocket from Cape Canaveral in Florida this month for the 10-day project inside the Orion capsule, the first manned trip to the moon since man first set foot on it back in 1968. The astronauts are back now and gave this reaction at a press conference.
You see your home planet, you see Earth eclipsing behind the moon, and it's just such a neat thing to see as a human being, and then once the Earth is out of sight, we know we can't talk to home anymore. And as the 4 crew members, that is when the science was actually getting the hottest and the heaviest for us. There was the far side of the moon is never seen by humans on Earth, and so we had a chance to see it. And we were seeing areas of the moon that had never been lit up during the Apollo era. So this is the first time 4 humans have set their eyes on the far side of the moon.
Dallas is one of the most knowledgeable experts in the UK and has presented on many shows like Stargazing Live. He has an impressive personal collection of space items, including actual dust from the moon, and has just published his latest book, Space Journal: The Art and Science of Cosmic Exploration. In it, he explores how popular culture has played a role in our understanding of what's out there, as well as how artists have inspired man's drive to reach the stars. And if you're a fan, like me, of Apple TV's MI5 drama Slow Horses, starring Sir Gary Oldman, you may have spotted Dallas in it. He's also acted in programs like The Crown and Rival. Dallas, it's fantastic to meet you. I alluded to space dust from the moon. Is that fact or fiction?
Well, it's half fact. It's actually what's known as lunar simulant. So we've got about 400 kilograms of lunar material on Earth that was brought back from the Apollo missions in the late 60s, early 70s, at a cost of, I was trying to work it out, at a cost of about 110 billion. That's what Apollo cost. Sending 12 people to walk on the moon and bring back some lunar material was pretty expensive. So it's quite valuable stuff. Most of it's in the Johnson Space Center, I think, under lock and key. And some of the Apollo moon rocks that the astronauts brought back were given to presidents and prime ministers and what have you. There's a bit actually in 10 Downing Street. So what I have in my little pot is what's known as lunar simulant. And the reason it exists is because it's so rare, the actual stuff. If we want to experiment with it, actually work with it, we need to create a simulant variant of it that's mechanically and chemically identical. So scientists can understand about what the moon is made of in order, as we go back to the moon and build bases on the moon, what can we use this stuff for? And the difference between dirt on the Earth and dirt on the moon is that everything on the Earth is continuously being recycled by the weather and by plate tectonics, and the Earth is constantly being recycled, as you will. So kind of material on Earth tends to get very weathered and worn down, etc., etc. But on the moon, it's not like that. The moon has no weather. It has no plate tectonics. So it's like this frozen snapshot of time. So the material that we get, even though it may be made of the same stuff of the Earth, it actually behaves very differently. It's very, very sharp, for example, if you look at the lunar particles under the microscope. And so what we've done is, I think we, not me, but what cleverer people than me have done is actually create lunar material on Earth that's identical in bulk. So we can actually create a lunar yard like they have at the Astronaut Center in Cologne where they train astronauts. They've made a big kind of warehouse full of this stuff so they can pretend to be on the moon, so they can better understand the material. And it is amazing stuff because in that material on the moon, we know there is water ice. So we can extract water ice from it. I think Blue Origin, Jeff Bezos' company, or a division of Blue Origin, they've made, just using this grey, looks like talcum powder material, they've made like a solar panel out of it. You can make silicon chips out of it. You can make computers out of it. It's unbelievable. It's like alchemy.
And how did you manage to get your hands on this?
I was doing a documentary. It was a Radio 4 program about building moon bases a few years ago. So I was at the Astronaut Center in Cologne, where they train astronauts, chatting to a scientist whose job it is to study this stuff and actually go, okay, well, what can we make out of it? We can make bricks out of it. We can make solar panels out of it. We can maybe grow things in it. We can extract water from it. And so anyway, it kind of ended up in my bag. I asked for permission and he said yes. So I've got it.
It's quite incredible. And what does it really teach us about the moon? I love the way you described it as it's a snapshot because of the way dirt here gets messed up by the weather and everything.
I think the thing is, when we went to the moon in the late 60s and 70s, we were only there for a matter of hours on the lunar surface. So we landed 6 times and we did a few EVA. So we're only there for a few hours. So there's only a limited amount of science you can do there. And each Apollo trip, a little bit like Artemis II, it's a 10-day trip. It's 4 days to the moon, 4 days back, a couple of days on the moon, doing moon things, hanging out with the clangers, whatever you're doing on the moon. But if we're going back to the moon properly, which is the idea this time, we're going to have to stay for some time. We're going to have to learn to live off the land. If you've been on a camping trip, it's fine to go on a short camping trip with a packed lunch. But if you want to stay for a long time, you're going to have to learn to cook and you're going to have to learn to forage and everything else. And it's the same on the moon. So how can we use this lunar material to actually survive on?
Tell us a bit about Artemis II and how interesting a mission was this for you to observe? Because, of course, now we're getting updates all the time, aren't we? Far more updates than back in 1968.
We live in a different age. We live in an age of always on media, constant 4K streaming and iPhones. It was interesting actually looking at the photographs that came back from Artemis II, which were obviously extraordinary, beautiful, incredible, just the sharpness of the image. But I noticed the difference in tone between those original Hasselblad photographs that were taken on film, which just have a different, like a different tone to them, a different flavor almost. There's a softness about them. And these are obviously much sharper. These are taken with Nikon Z9s, I think, and iPhone 17s. It's just everything looked a little bit different. But it was terrific. It was exciting. I think the thing that amazed me was just how receptive the public was to this. The politics on Earth at the moment is insane. Crazy things are happening. We live in a time of very divisive politics. And suddenly here was a moment where these 4 people, really amazing people, actually, really lovely people, we got to know them in a way that we didn't really get to know the Apollo astronauts because they were on all the time. These fantastic people going on this trip around the moon, first step in a series of many, I hope, and really conveying that enthusiasm about exploration and what's possible in the future.
I think the incredible thing is it made you feel you were there because there was broadcasting live into our homes. How significant is Artemis II in terms of where we are in our space history and what's coming next in the next few years?
That's a really good question. The trouble is with moon missions and any big space mission is it's very much at the behest of short political cycles and the political enthusiasm at the time. I remember when George Bush was the president, he said, right, Project Constellation, we're going back to the moon. And everyone got very excited. And it was used for political capital because everyone got very excited about going back to the moon. And then they realized how expensive it was. And Obama came in and it was cancelled. And this happens a lot. Long moon programs, which take decades to get right, when short political cycles happen, they very often get cancelled. So I don't know is the answer. The point about Artemis II is that I suppose the comparison is Apollo 8. Apollo 8, before we landed on the moon, did exactly this. They did a figure of 8 around the moon to test the engineering of the spacecraft, to see if it was possible. And the thing is about building a moon base, which is now the new idea, is that you don't just go from nothing to moon base. You have to do it small incremental steps. And so we have some of the hardware to do this, but not all of it. For example, we don't have a lunar lander yet. The Orion spacecraft that the astronauts were on can't land on the moon. So that's being developed by SpaceX and Blue Origin and others. So that's going to take a little bit of time. So you're hoping that the enthusiasm in the politics will continue while all this happens, because it'll still be a few years before we're living in Moonbase Alpha, if you remember Space 1999.
And what kind of things would the astronauts be doing on board? What kind of tests and what are they doing once they're actually in space?
So it was a test flight. If you think about bringing on a new airplane, for example, online, you have to test it. You have to fly it and test it and make sure all the avionics works and this, that, and the other works. And that's what they were doing. They were testing the mechanics of that spacecraft, as well as what is it like for humans to be in it. Because Artemis I flew Orion around the moon without anyone on board. And so things like, what is it like to live in? Things like radiation, things like checking all the astronauts' biometrics. So it was a big science experiment, making sure that it was safe, making sure things like the heat shield, which was a little bit problematic, was working okay, and all those things. And also, it was definitely a PR move as well. The photographs that came back were really, really important. It's really re-engaged our wondering about space exploration. The question I got asked the most by the press all the time was like, why haven't we been for 50 years? Why haven't we been?
And why haven't we been?
The ups and downs of politics. In the last 50 years, what have humans been doing? Well, in the late 60s, we were all about space exploration. And then we weren't getting enough back from Apollo, if you like. It was too expensive to continue indefinitely without getting a kind of return, if you like. And then we invented the internet and suddenly other things happened. We were exploring the online world and what that meant. And we had a digital revolution and all kinds of things happened. And so that looking out into space, for humans anyway, obviously there's been lots of amazing space projects, but certainly for humans, we built the International Space Station. Crikey, that's been permanently crewed for the last 20-something years. But the moon has always held a special place for us. The moon has always been a symbol of the unobtainable. So we've been distracted for the last 50 years, I suppose, by other things. And here's a moment where we went, okay, let's do this again. This is interesting.
I think a lot to do with getting the public around the world captivated again probably was the personality of those 4 people and the fact that we felt that they were kind of normal people in this extraordinary situation.
I totally agree. I think that is exactly right. I think there is something about the astronaut, about having characters attached to it, people that we can relate to, people that we like involved, brings the public on board. And if you're a politician, you need the public on board for whatever it is that you do. And astronauts have that skill. And even more so, I think the role of the astronaut has changed a lot. If you think about the astronauts of Mercury and Gemini and Apollo, they were all test pilots. That's what they did. They were test pilots. Job 1, stay alive. Job 2, control the spaceship. When I think of test pilots, you think of Chuck Yeager and all these kind of characters. And I've met a few Apollo astronauts and they're delightful. But the astronauts today, job 1 is be a good TV presenter, be a good podcaster, be able to reach out to the public exactly as you say. It's an important job for the astronaut, I think, the outreach side of it as it is as anything else.
And there was some exciting, captivating moments. At one point, they went past I know I'd never say this on a podcast, the point of no return. I think NASA lost contact with the astronauts for 40 minutes as they passed behind the moon. So we got kind of into that, didn't we?
You're exactly right. What is exciting about it, in any kind of story, and this is how humans communicate through story, you have moments of jeopardy. You have moments of jeopardy where you want to know what happens next. And here we have that perfect moment of jeopardy. Oh my goodness, they're going out of radio comms. What's going to happen as they disappear? And they're the furthest any human's ever been. And those exciting moments all add to the drama of it all. And we like that because what is space? What is space exploration? It's a good story. We love talking about it.
That's a big adventure. And also, so was their re-entry to Earth. Tell us a bit about that.
So they're traveling back from the moon. I'm going to probably get my numbers wrong, so forgive me. But a couple of 1,000 miles an hour, which is pretty quick. But as they get closer to the Earth, Earth's bigger gravitational pull makes them speed up, speed up, speed up. So by the time they go from the vacuum of space to hitting the top of the atmosphere, they're doing something like 25,000 miles an hour, which is like, what's that, Mach 36. Incredibly quick. And if you've ever put your thumb over and not that I'm suggesting you've ever done this, but as an analogy, if you put your thumb over a bicycle pump and pump, it gets hot. So what's going on there? Well, the air is getting squished, and as it gets squished, pressure builds up and it gets hot. And so the spacecraft coming into the thick atmosphere, well, it starts off thin at the top, obviously. As it gets thicker and thicker, the air is getting squashed, and as such, it's generating heat. But it's getting up to kind of half the temperature of the sun. And so what happens is you've got this heat shield at the bottom, which is ablating, so it actually burns off the heat shield. And that protects the astronauts inside. But it gets very, very hot. And again, a bit like going around the backside of the moon, all the radio communications disappear because you've got this plasma around the spacecraft, incredibly hot. And I've spoken to astronauts about re-entry, and they always say it's a bit like being in a car crash. It's violent, it's safe-ish, but they have to go from 25,000 miles an hour to about 15 miles an hour when they splash down. So going through the atmosphere is going to slow them down. And then parachutes open, that slows them down even more. And then they land in water, which is generally softer than landing on land.
What is it like when they get out? Is there a period of readjustment?
That's a great question. It depends on who you are and what you've been doing. So, for example, these 4 astronauts in Artemis II, they weren't in space for that long, only 10 days or something like that, a couple of weeks. And so their bodies will adjust to coming back to Earth pretty quickly. But if you've been on the International Space Station for 6 months in microgravity, your bones will become weaker, for example, because your muscles will have deteriorated. So that takes a lot of getting used to. Astronauts have been up there for a year on the International Space Station. So a year in microgravity will have profound effects on astronauts. And certainly when you see them coming out, particularly if they come back on the Soyuz spacecraft, which lands in the middle of Kazakhstan, they get pulled out and they can hardly move. They can hardly walk because suddenly gravity is heavy. We're used to it, but if you haven't been in gravity for a year, it's going to have profound effects.
And as a breed, are astronauts quite incredible people?
Yeah, I was chatting to one of them, John McFall, who's one of the new ESA astronauts, and he was saying actually astronauts are a bit like Swiss Army knives. They're good at a little bit of everything. It's not like to be an astronaut, you have to be the best at flying the spacecraft or the best at this, that, or the best scientist. You've got to be good at everything. And the reason is if you're going up into space for a long time, that's really expensive. And if something happens, you've got to sort it out yourself. So the thing about astronauts is they have to be highly capable people. And a lot of it, of being highly capable, is how do you deal with things in an emergency? If something goes wrong and you've got 30 seconds of air left to breathe, how are you going to deal with that situation? So there's a lot of psychometric testing, as well as, are you bright enough? Are you academic enough? Are you fit enough? Those psychometric tests to make sure you're not a kind of a lunatic. You know, can you imagine Donald Trump in space? Crikey. There's certain people that shouldn't go into space. I'm one of them, I should say. I'd be a terrible astronaut. And I know this because I've met astronauts, and I know I have the wrong stuff.
I know this because I saw the kerfuffle when you were trying to plug your microphone in a few minutes ago.
Exactly. Just basic stuff like trying to plug a microphone in and I'd fall apart. So can you imagine in a space situation?
Your space journal is literally hot off the presses.
It is.
It's really exciting stuff. Tell me what it's all about and what inspired you to write this one.
Well, first of all, it's a little bit of context because it's a history book. It's a history of space exploration. And here we are about to take this next step. And I wanted to write a book which tells people about how we got here in the first place. And so it's a history book. It's a book about people. It's a book about biographies, some of the people who are involved in space exploration. And I didn't want to just concentrate on scientists and engineers. Normally when we talk about space, it's science, it's engineering, it's numbers. And actually space exploration is a much bigger part of human culture. We've been thinking about space since we lived in caves. In fact, I notice in the Chauvet caves, which are the kind of oldest caves that we know of where humans have made marks, there's pictures of the Pleiades in cave paintings. So we've looked at the stars and we've wondered about the stars since forever. And we've also, in that time, we've thought about the stars and planets, not just as mysterious points of light or religious things. We've also thought about them as just worlds to be explored, a little bit like islands and oceans. And there is an analogy, I think, about the mariners of the 16th, 17th century, Vasco da Gamas and the Drakes and Columbus and everyone else. And space, there is that analogy to be made. And it's just something that's always fascinated people. And so the book is really a mix of different people, from artists and writers through to scientists and engineers to archaeologists to video game designers to a whole range of people. And I really want to give people a sense that space exploration is more than just a science and engineering story. It's a story about people. And it's not just biographies of the people. It's very much looking at what was it that inspired them? What were they reading at the time? So there's lots of images of backs of envelopes and notebooks and receipts. And I did a chapter about Galileo and we found a shopping list he'd written. And actually reading Galileo's shopping list is much more revealing than reading some of his academic.
What was on his shopping list?
Well, things like chickpeas. So he's obviously going to make hummus. He's a hipster, maybe. A new hat for his son. And then there were some weird things like, I need a couple of cannonballs and an organ pipe. And I thought to myself, Middle Isle of Lidl for that. And then we thought, well, why did you want a couple of cannonballs? And then I realized you need a cannonball because they're great for grinding glass into a lens. And then if you've got an organ pipe, put a lens on either end and you've got a telescope.
Gosh, that's incredible. But also when you look back at the Egyptians and things like that, and you look at the mathematics behind the pyramids, for example, which I don't know a lot about, but fascinate me the way they line up and they line up with stars and the planets. And how was all that possible? I mean, that shows, doesn't it, that back in Egyptian times, there was a real respect for what was out there in the sky and the stars and the planets and the galaxy.
I made a documentary about this for the BBC a while ago. And the accuracy of the pyramids is really interesting. And from memory, they were very astronomically astute. In fact, if you go in all the royal tombs or some of the royal tombs, there's stars painting on the ceiling. And the idea is that the pyramids lined perfectly up to what was the North Star. But because the Earth has moved slightly, so the North Star as we have it now is in a different place. The circumpolar stars would have made a little kind of star gate, if you like, a kind of empty space. There's still a hangover now of, I suppose, astrology. People link the stars to human fate and gods and all this kind of stuff. These are very human things and are very interesting, I think.
So I wonder where and how then that fascination really started when you were digging back in time and looking at the history of space exploration. Where does it all come from, Dallas?
Well, it comes from this wanting to know where we fit into the universe. Human beings, we're cursed with this self-awareness. We think about what is our purpose? Where are we going? Where are we from? Is it just us? Are there other people there? And we have this creative imagination. So we come up with ideas, we come up with aliens, and we come up with gods and angels. And I think the sky particularly has always been a canvas for our imaginations. We look at the sky. It's that opening bit in Hamlet, isn't it? Where they look at the clouds and go, methinks it is a camel. And you go, no, it's a weasel. We find patterns in nature, and then we apply our imagination to those patterns, and we come up with great stories. And I think it's almost like a join the dots puzzle. You look at the stars in the sky and you join the dots and you come up with a plough or Orion the Hunter. You come up with stories. Humans are pattern seekers. And science has taken this even further. And science is okay, well, maybe it's not actually a crab, but they're stars and we understand more about the stars. And science has given us a new chapter in all of this.
I'm just holding on to lots of questions about the book, which I've got, but it seems right to ask at this particular moment where your fascination came in. Does it come from you being a young child, having a telescope? Where did you get fascinated with the wider world out there?
It was probably that.
What is that? Describe that.
This is from a 1980s space Lego set. I'd build moon bases, and I didn't have enough Lego to build a cool moon base, so I'd use a shoebox and bits of tin foil. I grew up reading science fiction, and I suppose I'm of an age where Apollo had just happened. I don't really remember Apollo as it was happening. It was before my time, really, but it had happened, and that's what humans did when I was a kid. Humans went to the moon and had adventures and wore cool spacesuits. And I grew up watching Buck Rogers and Battlestar Galactica, and particularly in the 70s as well, I remember watching Close Encounters of the Third Kind, and I watched Star Wars. So it was just part of our culture. The message was clear as a kid growing up. The universe was filled with exciting adventures and exciting beings and aliens and places to visit. And so I wasn't really a massive space fan when I was a kid, but it was there underlying. And actually, it's really only in my career working as a science presenter and making programs about space and science more generally and meeting scientists and understanding, oh my God, what a cool breed scientists are, how creative it is. I had no idea. That's when I really became more and more interested in it.
And isn't it wonderful to be able to get involved in something for your career that you're really passionate about?
Well, if you do something you love, you'll never do another day's work in your life. If you do something that you enjoy doing, then it's not work. And sometimes they pay me. It's great. I worked as an actor early on in my career, and I've done some pretty crappy jobs in between acting gigs. But even the crappy jobs I was doing in between acting gigs, I quite enjoyed as well.
Yeah, you've done some good acting gigs. I love the fact you're in Slow Horses. In fact, I'm quite jealous because I've had as a presenter the odd little acting gig, like a newsreader in the very, very first ever Black Mirror, before we knew that it was going to be like a massive success and stuff. Yeah. But Slow Horses, God, you've overtaken me on that one. I love that programme. Was that fun to do your role in that?
Well, yeah, I hadn't seen it, to be honest, so I didn't know. I went in and did my day, so it was fun. But I started off as an actor. That was my original career, and so I did lots of telly and stuff back in the 90s. Being a factual presenter came a little bit later in my life, kind of by mistake.
Going back to your book, Tim Peake, astronaut obviously, describes in a quote on the front cover, he says your journal's a breathtaking glimpse at the margins of space history. You couldn't really get a much better recommendation than that. How did that come about?
I called Tim up and said, please read my book. And then didn't hear anything for a long time. I'm like, Tim, read my book. And eventually he looked at it and gave me a very kind quote.
And you broadcast on his historic launch, didn't you? The live launch to the International
I did. Yeah. No, I mean, I've been lucky. I know Tim well, and we've done many things together. So I was actually there for Tim's launch. I went out to Kazakhstan for his launch, and we've done various programs and things ever since.
That must have been really exciting, was it, being there for the launch?
It was. And actually, again, there's a history element which really appeals to me, because the place that Tim launched from is the Baikonur Cosmodrome, which used to be part of the Soviet Union. It's part of Kazakhstan now. But when you go there, we tend to think of space bases as shiny and silver and futuristic. It's straight out of the 1950s. Like, no one's washed a window there since 1957.
Is it really?
And so it's crumbling buildings. Yeah, because it's the same launch pad, the same rocket almost, that launched Sputnik and Laika the dog and Yuri Gagarin. So it's part of that. So I went to this legendary place and stood on this launch pad. I'm going, my God, this is where it all started. It's kind of ground zero. It's known as Gagarin Start. It's where the first humans launched. And here I am with a British astronaut. That's where Helen Sharman as well, the first British astronaut, launched from there as well. So it has this special place in history. And I wrote a little bit about it in my book. And also visually, it's so beautiful. There's something really beautiful about the space race from the 1950s. Actually, one of the interesting things, talking about the human element, the day before the launch, they have a big Russian Orthodox priest in black robes comes and performs this ceremony, this ritual, this communion underneath the rocket. It has this religious element, and we all gather around and we're all sprayed with holy water and prayers are said. There's a lot of superstition and rituals associated with space flights. And if there is something that taps into that part of our brain, we think of it as being very sciencey and clinical. But no, there's still a lot of that art, spirituality.
Yeah, maybe it's a spirituality thing. How incredible to experience all that and be there. I hope you took plenty of photographs.
I did. I've many photographs and 2 books worth of
2 books worth of material.
On it.
You also come out with incredible nuggets of information in the journal. One of my favorites is that you reveal that the first spaceship prototype sent into space match almost perfectly with illustrations made for Jules Verne's From the Earth to the Moon, which was written about 100 years earlier, wasn't it?
Yeah, I make the comparison between space exploration wasn't really built in laboratories and on scientific papers. It very much came from speculative fiction of the 19th century. Jules Verne, who was obsessed by Edgar Allan Poe and H.G. Wells, those 3 writers in particular, Poe, Verne and Wells, they were the inspiration for 3 particular engineers, a Russian called Konstantin Tsiolkovsky and Hermann Oberth in Germany and Robert Goddard in America, were all obsessed with Jules Verne. They were obsessed with this idea of going to the moon. And all of them realized that this was an engineering problem. This wasn't catch some magic geese that will pull you up to the moon. The people in the 16th century thought about getting to the moon. This was an engineering problem. And because of Verne particularly, they tasked it upon themselves to understand what it was. And they realized at that time that Newton would have something to do with it, Newton's laws of motion. For every action, there would be an equal and opposite reaction. That would be the fundamental thing. And then they kind of worked through all the details. And if you read Jules Verne's book, it reads a bit like a science journal. He is making calculations in his fictional way of doing it, but of course it's completely wrong. And these scientists knew that. But without Verne, eventually probably we would have got into space. But those, I suppose, forefathers of rocket engineering at the beginning of the 20th century did so because they were obsessed with science fiction. And it carries on to this day. I mean, you may have heard of this guy, Elon Musk. He's slightly controversial.
Tell me what you make of all that. Yes.
Crikey. Anyway, but he's always banging on about his inspirations, Douglas Adams, who I love, and Isaac Asimov. And so, yeah, again, it's this human thing. We do what we do because we love the stories and we want to make them a reality, I suppose.
The H.G. Wells and War of the Worlds gets a mention, but it really stood out to me because I spent a lot of my youth, or misspent a lot of my youth, playing Space Invaders, and I never knew that there was an H.G. Wells link to Space Invaders.
Yeah, there is. The little character, the invaded characters that we know so well, were based on H.G. Wells's characters, and also aquatic creatures. I published in the book some of the original sketches that the inventor of Space Invaders did. And he mentioned H.G. Wells and those famous aliens. And so it's reverberated through the decades. And actually, Space Invaders, again, was a very 70s thing. Aliens were a big thing in the 1970s. I think of Star Wars and Close Encounters that I mentioned, but Space Invaders is another one.
You also take readers on a deep dive into the architecture of spaceships and the design of space suits and also space gloves. This must have been great stuff to research.
Really fun to research. And I think actually spacesuits is interesting because there is a fascination, particularly with kids and spacesuits. Kids love to dress up. From my childhood, there used to be a TV show called Mr. Ben.
And he went into the dressing room and I remember him coming out as a spaceman or a Maasai warrior and then had an adventure, didn't he?
Well, that's it. So exactly as you say, when you put on the magic garments, whatever it is, you become that thing. That's why kids, not just kids, why we all love to dress up. Because when we dress up, we change ourselves. We become something different. And you said the word, and you're exactly right. It's that idea of adventure. And there is, particularly with the spacesuits, there is something iconic about the spacesuit. Watching Mr. Ben, I was always, make it be the spacesuit. Come on and put the spacesuit on. Very often when you look at photographs of the 20th century, the pictures they always use, is that picture of Buzz Aldrin standing on the moon with his arm slightly cocked, looking at the camera. But of course, you're not looking at Buzz Aldrin. You're looking at an engineered object. You're looking at an A7L lunar excursion suit, which was made by ILC Dover in Delaware, which was part of Playtex, who made bras and girdles and structured women's underwear. And all those women who made bras and girdles and women's underwear were brought on board to make these spacesuits because they were the best seamstresses and they understood how to work with different materials. You had this explosion in new materials after the war, things like neoprene and nylon and all this kind of stuff. And so that story, it's an engineering story we tend to forget about because we tend to think of crafts, sewing and that kind of thing as something other. But it's as much part of that space story as building rockets.
But even the gloves, the astronauts had plaster casts of their hands made to ensure that the gloves fitted properly. And weren't they made by seamstresses who were involved in the Apollo spacesuits?
Yeah. Actually, gloves are always really hard because the human hand is a very complex thing. When you're designing a spacesuit, you've got several factors you've got to figure into it. And one of them is pressure, because they have to be inflated, a spacesuit. Because we have air pressure down here on Earth, we don't have to worry about it. But as we get higher and higher, the pressure gets less and less. We need to take that pressure with us. So a spacesuit is inflated. If you inflate something, it becomes stiff. It becomes harder to bend. So the more you inflate something, the harder it is to actually move. And so there's always this trade-off between breathability and movement and flexibility. And gloves were always very, very difficult things to engineer. Actually, there was a good story. I don't know if it's true. I think it might be true. When Neil Armstrong and Buzz Aldrin and Mike Collins, after Apollo 11, they were sort of doing a world tour and everyone was throwing ticker tape at them and telling them how marvelous they were. And they went to Moscow. They were invited to Moscow, the American astronauts, and they'd taken an Apollo spacesuit glove with them, which I think got pinched. And if you look at the Russian spacesuits, I have one knocking around somewhere, the gloves are exactly the same as the Apollo gloves because they basically just nicked the Apollo glove design.
What is the future for you? When you look at the future, Dallas, what are the hopes for maybe the next decade and then looking further forward? What are we going to see? Because technology, science, data, it's all developing at such a rapid rate. It's hard to imagine, isn't it, where we're going next?
It is terrifying. I look at the world and we're inventing AI and AI is going to take over, but I still can't plug a microphone into a laptop. That's still beyond my capabilities. I don't know is the answer. And sometimes I think I do know, and then something crazy will happen. I look at the politics of the world at the moment, and actually I can see the similarities between the politics now and the politics of the late 1960s. We get misty-eyed about Apollo, but you have to remember that at the time America was bombing Vietnam. There were civil rights protests. Martin Luther King was assassinated in 1968. Politics was really messy back then, and it's pretty messy now. We're steering a course at the moment for this building a moon base to have a permanent presence on the moon. But again, we have to ask ourselves, why are we doing this? Because we are entering, I think, a period of another space race, a bit like the America-Soviet Union space race of the 70s. Now it's America versus China. What does that mean? It's about muscular politics. It's about who wants to be a leader in space rather than a follower. Space is becoming an increasingly important domain, not just for exploration, but for civilization generally. The fact that we're having this conversation now, I live in the countryside, so I use Starlink. We would not be able to do this if we didn't have satellites. You would not be able to order pizza with Deliveroo if we didn't have satellites. You would not be able to do banking online if it was not for satellites. So much of civilization depends on that. And that, of course, means that politics is going to play an increasingly important part. Is space going to become militarized? And so we're entering a period of excitement and deep uncertainty. And people say, well, what's going to happen next? Well, it's up to us, really. Where there's a will, there's a way. Where there's no will, there's no way. So if we decide we want to do things, then we should do it. But we have to be careful. I think we're in some choppy waters at the moment politically.
Yeah, I think we are. Choppy waters is definitely what we're in. But it's interesting that you said we have to look at why we're doing it, because that's a question I wanted to ask. And I didn't know whether that would seem a very naive question. But just taking the moon, for example, what is it that we want from the moon? Because the very nature of humankind is we always do things because we want something back. And I'm fascinated by the moon and its beauty, and I'm fascinated by what's up there. But when you're looking at it more politically, what has the moon, do you think, got to offer the leaders and the powers that be that want to drive exploration forward?
Well, first of all, you've said it exactly right. The moon has always fascinated us, all of human culture. Everybody who's ever been alive on planet Earth since the beginning of time has looked up at the moon. The moon has always been there as a constant presence. It's been a friend. It's been a screen that we project all of our emotional things on. We write songs about it. We fall in love with it. We have werewolves. The moon is part of all of our lives. It's also a place to visit. Actually, Galileo, really, in the 1600s, really for the first time looked at the moon and revealed it not just as this object in our minds, this perfect orb, but saw it as a real world full of craters and hills and valleys and mountains. And suddenly it became a destination. And so that was the thing it awoken in us. It's an object of scientific research. We want to understand where we are in the universe. And the moon is a great place to do that because it is this snapshot of the early universe. Nothing's really happened on it. There's no weather or anything else, as we discussed earlier. So it's a great place to do science. If we imagine that the universe is a great ocean, then the moon is the first stepping stone. But also, it's becoming a little bit like Greenland to think about modern politics. It's become this prize for land-grabbing politicians who can get to the higher ground. So it's become a political ambition. Does America want to let China put boots on the moon before it? And this is another bit of human nature, I suppose. The messy politics, ambition, greed. The moon is rich in all kinds of minerals and other things. So there's reasons why we want to get back for economic reasons. We know there's water on the moon. With water on the moon means you can stay there for a long time. You can make oxygen. You can make rocket fuel. And so there are economic reasons, political reasons, exploration reasons, scientific reasons, emotional reasons, tourist reasons. The moon is there as this prize.
And we can look out at it tonight and reflect on, well, I'll be reflecting on a really interesting conversation with you. I'm so glad, Dallas, you agreed to do the podcast with us. And I never really thought we'd be talking about the clangers, Playtex, bras and Space Invaders, but they were all part of our conversation today.
These are important things to talk about.
They are.
All of those things. Well, I hope people enjoy the book, and I want people to think about space exploration with a wider lens. And I think very often we think about it in a very narrow lens. When I was doing all various press stuff for Artemis, there's scientific questions. Oh, how fast are they going? Blah, blah, and all, which is all fine and interesting and good. But it's so much richer. And I hope the people that I write about will fascinate readers as much as they fascinated me. I fell in love with all these amazing people throughout time writing this book. I'm still writing it in my head. The crazy thing is the book's done and dusted and it's out. But in my mind, I'm still thinking about the people I wrote about. It was quite a journey writing it.
Well, I'm sure there could be room for Space Journal too, because all the people you've mentioned today and the many more that are out there in space's history, there's so much to say. And I think you did a cracking job of putting what you did together. It really is amazing. And I do hope people listening to this will check out the Space Journal. It's packed full of great information and facts. And I'm not any kind of expert, but I feel completely energized by what I've been watching and talking to you about this magical world out there. It's been brilliant to talk to you, and thank you for making time for us. We really appreciate it, Dallas.
Thank you for having me.
You're very welcome. You've been listening to space expert, presenter and actor Dallas Campbell talking us through the recent Artemis II mission to orbit the moon. Do check out his new Space Journal. It's packed full of great information and facts. Download and subscribe to our series at convex.podbean.com or search The Convex Conversation on Spotify, Apple Podcasts or wherever you listen to yours. I'll be back next week with another great guest. Join me then.